Hello, people. Welcome. This YouTube video demonstrates our website, which consists of different operating system algorithms. These algorithms are Priority Preemptive Scheduling Algorithm, Peterson Algorithm, First Come, First Serve Algorithm, and Optimal Page Replacement Algorithm. These are very essential algorithms that you need to learn if you want to understand the functioning of operating systems. Our website focuses on providing user-friendly environment using various React.js particles so that the users can understand the concepts easily. Well, this website is developed by Aniket Patel, Dev Chapatwala, Nupur Kapoor, Vishwa Nanavati, and Kushi Desai from PDEU, and it is mainly focused on simulating some of the important algorithms used in operating systems.
So this is our homepage where you can route to the various simulator of our algorithms and the team section and the chatbot as well. Coming to our X factor, we have 3 X factors in our website. First is based on the UI design, to make the UI design better. So we have used 3JS and loaded various 3D models in the website to make the UI design better. As you can see, there are various 3D models loaded on this website. This is not a video or an image. It is an actual 3D model where user can interact with. Coming to our second X factor, which is mainly based to make the user experience better, we have integrated GPT 3.5 in our website and made the chatbot for the same. So it will give the appropriate output as per the prompts I have given. So let's demonstrate that. Hi, I am Aniket. So it will generate the appropriate output as per the prompt I have given. Now let's ask who developed you. Okay, so it says the team members and who developed this bot. Coming to our third X factor, it is also based on making user experience great. So we have integrated voice assistant chatbot in our website. So basically whatever prompt I give to that chatbot, it will act accordingly. So let's demonstrate that. Go to Peterson. Simulate. So as you can see, it will act accordingly. Whatever prompt I'll give to the chatbot. So let's demonstrate more on that. Go to home page. Scroll to Peterson. Turn on dark mode. Scroll to team. About team. Reset. Turn on light mode.
Now let us see the priority CPU scheduling algorithm. Priority preemptive CPU scheduling algorithm is an algorithm used for scheduling processes in a computer system. It assigns a priority to each process and the scheduler selects the process with the highest priority of execution. If a process with a higher priority arrives while a process with a lower priority is running, the lower priority process will be preempted and the process will be executed. Now let us see the simulation. Here we are adding 3 processes: priority 2, arrival time 0, burst time 3, priority 1, arrival time 1, burst time 2, priority 3, arrival time 2, burst time 3. Here we can see the result, completion time, turnaround time, waiting time and response time. And here it is showing the gain chart of our input.
Our second algorithm is first come, first served disk scheduling. FCFS disk scheduling is used to manage the requests of multiple processes to access a shared resource at the same time. The algorithm works by selecting the request that has been waiting the longest, which is the one that arrived first. This way, processes that have been waiting the longest will be served first. Now let us see how the algorithm simulates. First we'll enter the initial head position 50. Then we enter the number of tracks 3. The output we get is the seek time and the graph.
Peterson algorithm. Peterson is one of the most widely used algorithms for mutual exclusion among multiple processes in distributed system. The algorithm works by allowing process to request access to shared resources and then ensuring only one process is grant access at a time. This ensures no process is blocked from accessing the shared resources and also makes sure that no two processes are accessing it simultaneously. Here is the algorithm for Peterson. The algorithm uses two variables flag and turn. A flag variable used true indicates that the process and wants to enter critical section. Entrance to the critical section is granted for access process PO if P1 does not want to enter in critical section and if P1 has given priority to PO by setting turn to 0. The algorithm satisfies the three essential criteria to solve critical section problem, that is, mutual exclusion, progress, and bounded waiting. Here is the stimulation for Peterson's algorithm. By clicking stimulation button, the two processes has been entered. Here the ball indicates processes, process P1 and process P2. When one process has been entered into the critical section, which is the shared part of a program, another process cannot be entered on it. If we try to enter, here the message shows. When the process P1 exits the critical section, then and only then the process P2 can enter on it.
Now let us see the optimal page replacement algorithm. This algorithm replaces the page whose demand in the future is least as compared to other pages from frames. The replacement occurs when the page fault appears. The purpose of this algorithm is to minimize the number of page faults and manage memory when a page fault occurs. Now we enter the number of frames. The user enters the reference string. Upon clicking the simulate button, we can see the result. The hits appear in green, whereas the page faults appear in red. We can also see other data such as the number of references, the number of misses, hits, the hit rate, and the miss rate. This was a simulation of optimal page replacement algorithm.